Hello, and welcome back to More on Maths. In today's video, we're going to be covering question 8 from AQA AS Mathematics 2021, Paper 1. For AI, we have to show this is equal to this. We can see the equivalent equation we want to get to doesn't have any sine or tan in its final form. So let's start by trying to get rid of these. One of our trig identities is sine theta over cos theta is equal to tan theta. If we sub this in the place of tan, we get 3 sine theta times by sine theta over cos theta is equal to 5 cos theta take 2. Expand this out. 3 sine squared theta over cos theta is equivalent to 5 cos theta take 2 again. Let's multiply both sides by cos theta to get 3 sine squared theta by itself, 5 cos squared theta, and negative 2 cos theta. Using our other trig identity, where cos squared theta plus sine squared theta is equal to 1, sine squared theta is equivalent to 1 take cos squared theta. That is equal to what we had before. Expand out this. 3 minus 3 cos squared theta is equal to 5 cos squared theta. Take 2 cos theta. Let's stick it all on one side. 0 is equal to 8 cos squared theta. Take 2 cos theta minus 3. Finally, we can factorise this to 4 cos theta take 3, 2 cos theta plus 1. That is equal to 0. You could have factorised this by inspection. However, another trick to doing it is letting cos theta equal x, for example. So we get 8x squared minus 2x minus 3. We need to find out what times what is equal to minus 3 times 8. We need to find what add what is equal to negative 2. You can do this by finding the factors of 24, and the ones that work in this case are negative 6 and 4. We then rewrite it, 8x squared plus 4x take 6x, 4x all times by 2x plus 1, take 3 2x plus 1 is equal to 0, and that rewrites as 4x minus 3 times by 2x plus 1. Substituting cos theta back in for x, we get 4 cos theta take 3, 2 cos theta plus 1. That's the same as that. It's just another way of getting to it. And we've got our equivalent equation, so we've done our first part. Now we have to solve this, and because we've factorised it, that makes it a lot easier. We have cos theta can be equal to 3 over 4. Cos theta can be equal to negative a half. Theta is equal to the cos inverse of 3/4. Theta is equal to cos inverse of 1/2. Cos inverse of 3/4 is 41 degrees, if we're rounding it to the nearest degree. That's one of our solutions. If we draw a cast diagram, labelling our quadrants C, A, S, T, standing for cos, all, sine and tan, we're dealing with cos, so we're going to be dealing with the all quadrant and the cos quadrant. If that's 41 degrees, then this is 41 degrees as well, but it's negative because we're going from 0 to 90, 180, 270, 360. We're going backwards into the negative direction because we want it between this range. So our other solution is negative 41. Cos inverse of negative 1/2. Our first solution is 120 degrees. If we draw our cast diagram again, when the angle is negative for a cast diagram, you mark off the opposites to what you'd do if it was positive. So instead of all and cos, we do sine and tan. That's 120, so this must be 120, but in the negative direction. So our other solution is there. So written neatly, theta is equal to plus or minus 41 degrees and plus or minus 120 degrees. For our final part, instead of just theta in this equation here, we have half theta. So our values of theta, we can write for half theta so now to get theta, we multiply by 2, giving us what would be 82 degrees for this, but actually it does round to 83 now, because to more significant figures, this was 41.4096, so doubling that goes to 82.8, which then rounds to 83 degrees. We're keeping the plus or minus. The 120 plus or minus goes to 240, which is outside of this allowed range, so we can't have that, making our only solutions plus or minus 83 degrees. Feel free to check out the rest of our More on Maths channel, where we'll be posting similar walkthroughs in the future. Please consider subscribing so you don't miss a video. Thank you for watching.